This conference will now be recorded. This conference will now be recorded. This conference will now be recorded.
Hi audience, this is Shiva. Um, we are going to discuss for a moment on performance engineering versus info and network analysis. So we are proposing a training from Isha Technologies, Technical Training Solutions. Uh, Please be enrolled for 12 to 15 hours of session. This will give a guidance on a performance tester or a performance engineer who can do a minimal analysis on infrastructure as well as on network analysis. In the part of is controller test audit of a performance test or an engineering performance engineering analysis from application towards infra and network analysis. By the way, I'm Shiva. I'm having 12 plus years of experience. I also worked on a performance tester, APM, monitoring, performance engineering, and architectural sides. I also having experience on different monitoring tools. Today, I'm going to give a brief session on infra network analysis for the performance engineering candidates. So please be enrolled and please contact Mr. Kumar Gupta for the enrollments. Fine. I just give an introduction before going to infra network analysis. What would be the real candidates for infra network analysis? So we do performance testing. Say our application is bearing a load of 100 users. I mean to say we are doing a performance test within 100 virtual users from a virtual user load generator that loads on the system. So it sends the load to different system servers. So whenever it get responded, then we start doing analysis by using controller. That all we know. In the part of performance engineering, we give more importance towards analysis on the application side. So what kind of bytecode, or what kind of database, and what kind of application issues or taking majority role. There's another aspect as well. That is that is infrastructure and network analysis. So that is also plays a vital role of in a response time or in a performance of the application. Say example, if you're working on a login transaction, you are keeping virtual users load by using a virtual load generator on a system which outputs the successful login. That means every virtual user hits on the system for a login and it should be responded within the SLA. So for example, in our case, take 100 users as an load and 2 seconds is the SLA. That means the most of, 90% or average response time should be within 2 seconds for a successful login transaction. Once you kept a load for an hour or you still working with a load between an hour, you get to know what are the response times going on. So once you get into the once you're done with the test, you just go to the controller or a related system for your analysis and reporting purpose. In the reporting, your team, like your engineering subsidiary team, say architectural or management team says that I need more analysis from infra side as well. So this is the starting point for the importance of infra and network analysis, because there are some too many migrations are happening, like 60 to 70% of projects are migrating with respect to application and with respect to infra and network as well. So, and the most of the systems are moving into the cloud, and most of the systems are running as in microservices and CI/CD pipelines and DevOps systems. In this case, infrastructure is playing vital role. In earlier days, all the systems are running on a legacy kind of infra model. That means data center model. Yeah, data centers maintained by the customers or a product owners. Okay, so that is a bit hassle-free, easy to think, easy to architect the application load, distribution, and the sections of performance testing. But nowadays, it is being differentiated, like whether the application infra is working on a containerization part, I mean microservices and the Kubernetes orchestration, or it is running on a SaaS, direct SaaS machines, which there is no data center like a physical system model. All the machines are virtual machines. Yes, or or the data centers are being maintained by the public and private cloud combination. I mean hybrid cloud kind of combination. In that case, processing the network is a challenge, and analyzing network is in should be gain knowledge for any performance engineer, and you should have to be in the position to understand the infra, how your response time is being processed from infra, not only from the application. So by considering that kind of performance engineering tactics, I wanted to make you in hands-on session within a practice-oriented real-time scenarios. We are planning to have this session. So this session is an overview which helps you to get into the just like first steps to analyze the infra network analysis, what it goes, how it goes. I'll try to give an example. Suppose you are testing an application. The same example what we discussed. I mean what I informed you and just few minutes back. 100 users load. You're testing a login. I mean you're engineering for a login transaction, and the SLA is just 2 seconds. So 92% of users from the desktop machines and 75% of users from other devices, 81% of mobile users. Hope you understood this point. Like my application login can be happened from anywhere, any kind of device. I support three devices. One is from the desktop, from Mac machines or Windows or Linux machines, and mobile devices, Apple, Windows, iPhone, and Android, and the other devices like tablets and iPads. So if I keep in 100 users of load, so 92% of users from desktop which are using processing the login transaction from desktop, 92% of users are falling in SLA. That means 92% of users are getting response time less than or equal to 2 seconds. Rest of the 8% of users are greater than 2 seconds. If you come on to the same for mobile device, 81%. If you come on to the same kind of other devices, I mean tablets and other gadget kind of devices, it is 75%. So from application, you can able to see the same code is distributing. I mean, same code is being processed for the login. But the matter here is this user, this particular user, from which device he is choosing to log in your application. That impacts your network and that impacts your infra. That means by using which infra user going to log in, and as well by using which infra server is going to be handled. Example, all the mobile devices are coming from the different OSs: Android, Windows, iPhone. So here we need to fetch up some infra challenges and network challenges to report and analyze why the SLA is different for a gadget. So this is another starting of point. This is the real-time burning problem for almost all applications. This could not be the same for all. So, but customer expects I need 90 greater than 90% of SLA to be reached by any system login. So take over this challenge. You should be not on. You should be in the position to engineering with respect to performance from other infra sites as well. And what we are going to see here, this is just a blue screen. Yeah. So consider. Let us take an example. This is one of our request input, and this WebGR is output. If we need a colorful output, that should be processed through infra. I mean, application request should be processed through an infra. This clearly denoting that importance of the infra and network. So if we need a perfect output, we should also need to be maintain the related infrastructure. Say, let's take an example. Your infra is built for 80 users, but as per our example, now we are hitting with 100 users. So rest of the 20 users would be in the queue always, because infra capacity according to your application processing request size the sum of request size is greater than the infrastructure capacity. So you need to take off this with capacity planning team and other infra teams. So the infra is playing a vital role to process our request as expected, and the fastness of the infra also impacts the performance of the application. Now, what kind of infra? Now we are going to establish. See, nowadays everything coming onto the virtual. Even our meetings are happening in virtual, even missions are virtual, servers are virtual, or cloud is a virtual. So we have different virtual infrastructure being placed by an application. Say virtual machines, data centers, vCenters, clusters, Hyper-V machines. Everything is virtual nowadays. So if you take an example of an end-to-end application, say example, if you take an e-commerce site, an example, your search option may be run on some different technology. Once you place order, if you click on order button and you processing your order, that order processing would be run on different system. So the combination, the integration should be uh, perfectly mapped between the two different application infrastructures. Then only the handshake would be happen correctly, and the network would be processed as expected, and the system flow will be run as per the architected. Then only we can able to see the expected response times as per the design. Now, I'm going to give another example. Let's take an, see, he is my user and he can able to place the requests, okay, from a machine, from another electronic gadget, and from a mobile, and from an internal sources, other sources. Finally, it will be centralized through a cloud network. I mean cloud infra as well. So in case my user, now he coming to here all the way, and he's taking his mobile and he's going to place a request. So here I'm going to explain infra side. Just keep aside of application analysis. That is also equally important, but our topic is now we need to uh, look over on the infra network side. So now the example is this user coming and placing a login transaction here, and this login transaction reaching to this server. I mean this infra, cloud infra, and you'll get, once the request has been processed, I mean if the valid user is valid, then the response would be processed back by the system within the SLA time. That means the request and response times would happen less than or equal to 2 seconds. That is our SLA. Now, so in infra and processing requests, we have a processors, and this processings, by taking infra, we have different kind of algorithms. Say most popular, and 99% of systems are using two types of algorithms: sticky notes and round robin. Say sticky notes. Now this user placed a request, yeah, today morning, and now evening also is going to place another request. So what sticky notes will do, whenever this user first visit in today morning, system notes his username, I mean some unique identity, and whenever he visits next time with the request, he will be get first prioritized, and he need not to get any security checks, I mean major security checks. So this major security checks would not be happened for this valid users. Okay, next visit. So user information or request information. The best suitable word is request information. Request information would be captured by system processor, and it stores whenever the same kind of request revisits. The next request would be processed more than the first request. That means first request is processed in 1800 milliseconds. Second request may be processed within 1600 milliseconds because it is having the rest of the 200 milliseconds data processing time. So it saves the time. And round robin. Yep. So the best example for round robin is a sprinkler drizzler. If you see in the big lawns, there is a water sprinkler out there. Whenever request comes up, it will rotates in 360 degrees and distributes the water to the no, what at the angular area it has been shooted out. So in that way, we have three systems here, three servers, and three infra devices are there. So according to round robin, when the request has been in place, then immediately it checks out very fastly which of these three are in the position to take up a load immediately. So this middle system is ready to take up this load, then immediately this request would be processed to this queue. So this kind of algorithms, how it works and how internally the systems would be processed at the request, we will discuss in this session. And connection poles. There are database connection pools, there are application connection pools and web connection pools, which are related to the infrastructure. According to the infrastructure capacity and capacity planning, we decide the connection pool size. Say, according to my request, according to my system, my connection pool size is 500. So you continuously making all the request from this way and from this way and from this way and this way at a time, constantly. Load is within the 500 means your load will be processed immediately without managing any queue, because the pool size is 500. So that means your pool can process 500 requests at a time. If what happens, 500 and plus requests, instantly there is a load now on this particular connection pool is 520. So those top last 20 requests would be managed in queue, because our connection pool size is 520, 500. Load is 520. So the rest of the 20 would be in the queue. They would be immediately processed by managing the queue. So this kind of examples also we are going to discuss. This impacts our real-time response times, and we need to know what is the connection pool details and how they are processing with respect to infra, and some points in capacity planning as well. I also wanted to inform you that once the request has been processed, the infra would be managed in different aspects. Once it has been fetched out, there would be a firewall here. Okay, that also considers in the response time. The firewall check also fall under the response times, and that also in the part of your performance area, because it is also considered some recommended response time. Yeah, and servers and SNMP devices. Yeah, fine. Now, why actually importance of why we need to give an equal importance to infra? Why not earlier? Why now? Earlier we have different kind of infrastructures, Linux based or Windows based, or you have together on an internal network. But now everything is being changed. Things are moving very fastly. And earlier days, if an application launcher release would be happened quarterly once, half yearly once, or yearly or twice in year max. These are the fastest build processing releases in this. But nowadays, we are working on the DevOps culture. So what DevOps will do? They were working on a CI/CD pipelines, continuous integration and continuous deployments. In that, continuous delivery now. It is not being called as a continuous deployment, continuous delivery. In the part of continuous delivery, every application is divided into microservices. Every application services are divided into microservices. Every microservice is pulled into a Docker and a container, and they are making orchestration. And that Kubernetes example, Kubernetes is in a best orchestration. I mean, most popular. So once it has been orchestrated through Kubernetes, then it is an eligible candidate to make out continuous integration with the systems and continuous delivery. So every day we have 10, 15, 20, hundreds of deliveries happens over the system if you consider as an end-to-end system. So where the system, like where the culture came now from the quarterly release to daily 100 releases, all are minor. So risk free. If we have 100 microservices to be deployed today, divided into 100. In earlier case, there is a build, a big tar file, and that tar file is impact any small piece of code is failed, then immediately You need to either roll back, or you need to stop the build, or you need to redeliver it. Nowadays, everything is considering into parts and pieces of the application, small pieces, I mean small microservices. So if that microservice is impacted, just pull out that only microservices, rest of you can process it. So on the same way, the entire system is now working, whether it is in a Linux, Windows, that doesn't matter. It is in a virtual machine where, and Azure, AWS, Google Cloud, Oracle Cloud, IBM Cloud, what you take, everything running on an like microservice orchestration. In that place, we are very thoroughly, we have thorough understanding on the infra as well, how the systems are making changed. I will give a good point, another good point to make you a gripped one. Let's say example, you're uh, taking your service as an Azure, and you wanted to launch your products in Australia, and you need to do testing also in Australia, but you do not have any infrastructure in Australia. So what you will do in earlier days, you need to rent out, let out, or purchase a small size data center, or you manage a server altogether, and you need to manage the server up and downs. That means you need to make some hard enable a hardware engineer and network engineer, and you need to manage the support to make your system continuously up and running for no impact on customers. But nowadays, if you wanted to test your application for some days, for 7 days, take an Azure service for 7 days, pay as you go. Whenever you are using this particular system, then only you get charged. If else, no. And the infra would be maintained by Azure. I mean, whatever the cloud service provider, Azure or AWS, and they will take charge of their up and running. They were providing securely up and running your system. They're managing your system infra. So altogether, you need to make over that. You need to placing a right application. So how it is being changed from infra maintenance to zero maintenance of infra. Just pay as you go. If you are utilizing that infrastructure, you pay. Else, no. If you are working your performance testing application for a week, you pay for a week. That's it. Done. If you're continuously launching an application, there's another story. Nowadays, like you're just working with an application with 10 users, just 10 users of load. You need to keep a small system, but your business growth is very good. Immediately within a month, it has become good growth with 100 users, constant hits. Then that is a big challenge to you in earlier days. You need to set up a new hardware, and you need to set up engineers, you need to set up this support. But nowadays, it is auto-sized, and that risk can be taken by the cloud service provider. It immediately resizes your application, I mean infrastructure, how much amount you want. Hassle free. How much bit server? 64-bit, 128-bit. How many bits of server you need to be increased? What is the RAM size you want it to be make up? What server you need? And the migration. They're maintaining the data lakes, data breaks. That is very easy. Instead of using very big data, Hadoop and other systems, we have data lakes here. So infra is changing very drastical, positive growth. So we need to be in the position to give and understand to the customer that, yeah, I am also having knowledge on this side. So that helps you if you're switching, that helps you like in a new system. Yes, he is the guy, he can take up the things. So that kind of confidence I wanted to build through this session. Fine. Now, continuous monitoring, continuous feedback, and we need a customer feedback. Now, all the systems are trying to come out DevOps cycle for operations. So for continuous monitoring in the DevOps cycle is a major challenge. Once you completed your performance testing, once you get a sign off, like this is the real example, like our example, 100 users, and you tested with 100 users, and you said that SLA is 2 seconds for 90 greater than of 90% users. So you need to ensure in the same in production as well, that you worked on, you engineered, and you analyzed this and in a production size of system, or in a 50% size of production or some other size of production compared to the production system. And now you, once you're getting sign off, that means I also ensures that the same values with very less impact, I mean here and there, I mean tentatively equal to, right? But you also need to ensure continuous monitoring sometimes. Say your systems and your servers also being to be monitored within the product. Like if you're doing a performance testing, you also need to monitor the system. So to sake of that, we need to check out the infra, which node is down, which node is taking high response time, and why. What is the PICE, performance impacted events, with respect to network, and where is there any TCP loss, what are the transmission errors, and what is the received errors, why the network is being uh, fluctuated at this point of time. Is any of my monitoring tool has been taken any screenshot of the system with respect to infra and network. So for that sake, we also having some minimal knowledge in the monitoring tools. That is also equally important nowadays. So I wanted to show you 1 or 2 hours of sessions on the monitoring by using the monitoring tools, like market leading monitoring tools such as AppDynamics and Dynatrace. That is also helps you to monitor the system. So you get to understand that. So this is the idea, what we are going to plan, and like even have to give a glance on how we can approach with infra network analysis. Hope you are good to go with this. Yeah, this is in a 12 to 15 hours of session. Uh, this is an informative session that you can also take up the things for analysis. So to build the confidence, this session will be very helpful to you to engineering some performance issues. And we are going to start the session soon. So please enroll the session with Mr. by consulting with Mr. Kumar Gupta. Yeah.